Hello and welcome. This is going to be our lecture video for December 10th. We're going to be doing another step-by-step binder lesson today. You can do this on a separate piece of paper, or you can print this off of the extra stuff calendar. All right, how do we solve an absolute value inequality and graph its solution? Step 1, we need to isolate the absolute value. And we do this using inverse operations in the balancing method. Inverse operations / balancing method. All right, and this will come into play several times, but you need to remember to flip the inequality if you ever multiply or divide by a negative. So that rule still applies. Okay, step 2. After you have isolated the absolute value brackets, you want to split the inequality into the positive and the negative case. For the positive case, you're going to drop the absolute value brackets. Drop the brackets. But in the negative case, you're going to replace the brackets with a negative parentheses. This deals with the situation where the expression inside the absolute value is negative and the absolute value brackets need to flip it back to being positive. So how do they do that? They multiply it by a -1, because a negative times a negative is always positive. All right, step 3. We need to solve each side separately. Finish with the variable on the left. If it's not on the left, then flip the entire inequality to get the variable onto the left. And again, we need to remember this rule I wrote up here. Flip the inequality if you ever multiply or divide by a negative. That's guaranteed to happen in one of the two cases, either the positive case or the negative case. All right, but we're not done yet, because this will just solve it. We need to solve in graph. So in step 4, we need to graph each inequality separately with the correct dot, which can be either open or closed, and arrow, which can point either left or right. All right, when you do this, the two arrows will either connect or separate. Right? They will never be going in the same direction, though. They're either, if one's going left, the other one's going right. Step 5. If they connect, write and you can rewrite your answer into a single line inequality. Example, if x is greater than 3 and x is less than 5, this here becomes 3 is less than x is less than 5. If they separate, write or. Okay, so there's our 5 steps to solving. Now we've got 5 problems to practice this with. Let's go ahead and try this with problem number 1. The absolute value of b is less than or equal to 6. Step 1 says isolate the absolute value. It's already isolated. Step 2 says split the inequality into a positive and a negative case. So in the positive case, we drop the brackets. B is less than or equal to 6. In the negative case, we replace those brackets with the negative parentheses. Negative parentheses b is less than or equal to 6. This side's already solved. We can put a circle around it if we want. This side over here, we need to divide both sides by -1 before we get b is greater than or equal to -6. Notice we just divided by a negative, so we need to flip the direction of our inequality. But we do not know if we should put the word and or in between these two answers until we go to the number line. All right, let's graph these separately. B is less than or equal to 6. I should put a closed dot at 6, arrow going to the left. B is greater than or equal to -6. I should put a closed dot at -6, arrow going to the right. These will connect up, meaning that I can say and in between these two answers here. Or I could rewrite this as a single line inequality. I could go -6 is less than or equal to b is less than or equal to 6. That would also be an acceptable solution to this one. All right. Absolute value of x is greater than or equal to 8. Absolute value is already isolated, split into the two cases. X is greater than or equal to 8 and negative parentheses x is greater than or equal to 8. Divide this one by -1. We get x is less than or equal to -8. Closed dot at 8, arrow going to the right. Closed dot at -8, arrow going to the left. We go back to our two answers. And we write the word or because these two arrows separated. They did not connect into a line segment. All right, number 3. The absolute value brackets are already isolated, so we can split this into the two cases. Neither will be already solved, though. 8 plus n is less than 9, and negative parentheses 8 plus n is less than 9. Over here, I'm going to subtract 8 from both sides to get that n is less than 1. Over here, I'm going to distribute in this negative. We get -8 minus n is less than 9. I'll add 8 to both sides. I'll get that -n is less than 17, divided both sides by -1. And I get that n is greater than -17. Notice I flipped the inequality. Let's go to the number line. At 1, I put an open circle, arrow going to the left. At -17, I put an open circle, arrow going to the right. These do connect into a line segment, so we can write the word and in between. And we could also rewrite it as the single line inequality. -17 is less than n is less than 1. Number 4. Now the absolute value bracket is not isolated. I need to isolate it. Let me copy it down over here. Absolute value of n minus 5 minus 10 is greater than -5. I need to add 10 to both sides. Now I've got the absolute value of n minus 5 is greater than 5. Now I can split it into the two cases. N minus 5 is greater than 5, and negative parentheses n minus 5 is greater than 5. and solve each separately. Plus 5 plus 5. I get that n is greater than 10. Distributing the negative over here, negative n plus 5 is greater than 5, minus 5 minus 5, negative n is greater than 0, divide by negative 1, divide by negative 1. N is less than 0. Notice I had to flip the inequality. Let's go ahead and graph it. Open circle at 10, arrow going to the right. Open circle at 0, arrow going to the left. This was an OR type all along. And our last one, negative 3 times the absolute value of 6x minus 7 minus 8 is greater than negative 65. I need to isolate my absolute value bracket, so I'm going to add 8 to both sides to start. Moving their constant is always easiest, so negative 3 times the absolute value of 6x minus 7 is greater than negative 57. Divide both sides by negative 3. I just divided by a negative. I need to remember to flip my inequality symbol. So now I've got the absolute value of 6x minus 7 is less than, I believe that's 19. Okay, we can split it into the positive and the negative case now. So in the positive case, we get 6x minus 7 is less than 19. And in the negative case, we get negative parentheses 6x minus 7 is less than 19. Solve these separately. I'll add 7 both sides here. Get 6x is less than 26. Divide both sides by 6. I get x is less than, that's 4.333. I want to double check that. 26 divided by 6, 4.333, good. And distribute the negative. Negative 6x plus 7 is less than 19. Minus 7 minus 7. Negative 6x is less than 12. Divide by negative 6, divide by negative 6. Just divided by a negative number. Again, I need to flip my inequality. So x is greater than negative 2. Not sure if I should put the word and or until I go to the number line. Open circle at 4.333, arrow going to the left. Open circle at negative 2, arrow going to the right. They do connect up, so this was an and type compound inequality all along. All right, they've all been solved and all of them have been graphed. I'll embed a few more here for you to try, but that's the end of our video. Have a good rest of your day.